Okay, topic 9, exponential growth and decay. Sorry for the like buzzing noise. I've been trying to turn it off and I can't, and it bothers me just as much as you. I think, wait, no, that sounded, okay, whatever. Anyway, exponential growth and decay. So exponentials are really cool. They are functions that, like, their whole kind of deal is like repeated multiplication. So like we could have something like an exponential function would be like y equals 3 to the x. And so every time we change the x, like if we do x equals 0, well, that means 3 to the 0. Well, 3 to the 0 is just 1, remember? But then if we do like at x equals 1, then that's 3 to the 1, which is just 1, that's just 3. And then x equals 2, that means 3 squared, and that's 3 times 3, which is 9, okay? And then if we do x equals 3, that's 3 to the 3, which means 3 times 3 times 3, which is 27. And it just keeps like going up like this. So we get like x equals 4, which is 3 to the 4th. So that's 3 times 3 times 3 times 3, which is 81. Wow. So it's just going to like take off. You've probably been hearing a lot about exponentials recently because exponentials is like how viruses spread and stuff, right? Like if we were to think of if one person gets sick and then they get 3 more people sick and then those people each get 3 more people sick and then those people each get 3 more people sick, it spreads really, really fast. So that's one of the reasons why we're not in school is we're trying to like slow the spread of this exponential, exponentially spreading disease, and that's why it's spreading so fast. So exponentials are really important, especially right now. The scientists that are studying like the COVID-19 stuff are looking at exponentials. So really kind of neat. But let's look at a couple examples here. So this first type of problem says identify the initial amount, the rate of change as a percent, and evaluate at t equals 5. And they gave us a problem right here. So it says y equals 5 times 1 plus 0.36 to the t. This is the initial amount right here. So the number in front of the parentheses, it's not being raised to the power, it's just right there. That's the initial amount, and we'll call that a. So in this example, a equals 5. The rate of growth, we have to look on the inside. Okay? The 1 on the inside, that just like makes it stay the same. This, the extra stuff, like the plus 0.36, this is what's going to make it grow when we multiply it. So 0.36 is the growth factor. We want that as a percent. So in order to get that as a percent, we have to move the decimal point over 2 places. So it ends up being 36%. So I made a little space to put that, 36%. So the growth rate here is 36%. So you have to look at the stuff like the extra stuff more than the 1. That'll be the growth factor. And the last thing it wants is for us to evaluate this at t equals 5. So like in our calculators, we're going to have to type in 5 times, okay, 1 plus 0.36 is just 1.36. So we could just write that. But then where the exponent is, we're actually going to put the 5. So it would be like this. Okay, okay, I just learned how to do this. Let's see if I can do this. Look at that. Oh my gosh, that's so cool. Okay, so we're typing in 5 times, in parentheses, 1.36. I got to go to the exponent and I need to put in a 5. Oh, 23.262. Okay, we're going to say that it says round to the nearest, let's see, hundredth. I'm going to say hundredth, so that's 2 decimal places. So we're going to say that that was about 20, whoops, that's not a 2, 23.26. And after that comes a 2, so we'll just leave that as 23.26. 23.26. Nice. Okay, what if I turn this sideways? Oh, even better. Okay, so nice. We got that one. That's everything. So we got the initial amount is 5. The rate of growth is 36%. And at t equals 5, we have 23.26. Okay, let's look at another problem. It says write a function in terms of t, so that means that our variable is going to be t, that represents the situation. A population of 210,000, okay, increases by 12.5% each year. Okay, we're trying to write a function. So we're going to write y equals, can I change my color over here? Whoa, cool. Okay, y equals the initial amount. So we started with 210,000 people. Am I going to need to use my calculator at all? I don't think I am. Dang it. Okay, well, fine. How do I make this go away? No. Oh, that's cool too, though. That's neat. Just go away, please. Just get back into this. Oh, okay. Anyway. Okay, y equals 210,000, that's the starting amount, and then in parentheses it's increasing, so we're going to have 1 plus, 12.5%, 12.5%. We need to put that right here, but it has to go in as a decimal instead of a percent, so we need to move the decimal point over 2 places, so I'll go right there. So we're actually going to put in 1 plus 0.125, and then to the t. So that's the equation that we write. That is the function. That's our final answer. So if you have to put this into big ideas math, just make sure you put the parentheses in and make sure you get up to the exponent. You can hit the caret button on your keyboard. It is above the 6. Above 6. Or on big ideas math, they have like a little keyboard that will send you up into the exponent or something like that. Yep. Okay, cool. One more of these. Write a function in terms of t that represents situation. So we're going to use t again. A $900 sound system, so you buy it for $900. Okay, it's going to decrease in value because eventually it's going to become like obsolete and you'll want to buy a new one. And it's going to decrease by 9% each year. Okay, let's write an equation. So we have y equals, it always starts with y equals. The starting amount was $900. Okay, and then it's decreasing. So we have 1, since it's decreasing, it's going to decrease, so minus, 9%, but we need to write that as a decimal. So we need to move, we have 9%, but we need to move. So go from here to psh, psh. And whenever we have an extra, we have to put in a 0. So this is 1 minus 0.09 to the t. And that's our formula. Another way to look at it is like it decreases in value 9% each year. So that means it keeps 91% of its value, right? If it decreases in value 9%, it keeps 91%. So another way you could write it is like y equals 900, because it started at 900, and then it keeps 91%. So you could just do like 0.91 to the t. It's the exact same thing, but just another way to look at it. So, okay, that's that. So you might have to use one of those calculator apps on these ones where it says like evaluate at t equals 5. So I would get one of those good calculator apps. The Desmos app would work well. I recommend, and this should have already seen this on Canvas, but if you have like an Android device, I recommend Wabbit Emu. It's free. It's an emulator. And if you have like a iPhone or iPad, the one I have is Graphing Calculator. It's like Graphing Calc X84, I think is what it's called, something like that. So, and that was free also. So, alrighty.